Now, in this problem, we are asked how many grams of oxygen are needed to completely react with 7.4 grams of carbon monoxide, and how many grams of CO2 we will produce from this reaction. Okay, so again, in any time we're dealing with these stoichiometry problems, we need to begin with a balanced chemical equation, which includes the mole relationship. So 2 moles of CO reacts with 1 mole of O2 and gives us 2 moles of CO2. So we know the mole ratios and we know the molar masses of each of our compounds because we will always have a periodic table around, or at least hopefully we will. Okay, so we know that 1 mole of CO is 28.01, 1 mole of oxygen is 32.00, and 1 mole of CO2 is 44.01. Remember, we want to use 4 sig figs when we use atomic and molar masses, so that we're all dealing with the same numbers. Okay, and these give us these gram-gram relationships. So in this problem, we want to go from 7.40 grams of carbon monoxide, and we want to find out how many grams of oxygen we need to use. Now, to do this, we can't simply go directly from grams to grams, but we must take into account these molar ratios. Okay, and so to do this, we're always going to follow a standard strategy, and this is true anytime you are given a mass in grams and you need to go to a mass of something else in grams, whether that something else be another reactant or it is your product. You're always going to go from grams to moles to moles to grams, and this should be your mantra for this type of a problem. So we're going to go from grams of carbon monoxide, we're going to go to moles of carbon monoxide, knowing that 1 mole of CO weighs 28.01 grams of CO. And now my units here cancel, and when I do this conversion, I convert to moles. Now, before I plug this into my calculator, I'm going to go ahead and go to the next step. I'm going to say that I need to react 1 mole of oxygen for every 2 moles of carbon monoxide, right? Based on our molar relationships that were given in my balanced equation. Now, again, my units have canceled here, and now I'm going to go from moles of oxygen to grams of oxygen. 1 mole of oxygen weighs 32.00 grams per 1 mole of O2, and my moles cancel. So I'm going from grams of one reactant to moles of that reactant to moles of my other reactant to grams of that other reactant. Okay, and this is going to be our standard strategy. And so now in my calculator, I'm going to take 7.40 divided by 28.01 divided by 2 times 32, and this will give me 4.22 grams of oxygen. I'm given 3 sig figs in my starting value. I'm going to report 3 sig figs in my solution. Okay. Now, the second part of the question is asking how many grams of carbon dioxide do I get? Well, we're going to follow exactly the same strategy. And again, we can begin either with grams of oxygen or grams of carbon monoxide. It should give us the same answer, assuming that we did our work correctly up here. Okay, so I'm going to start again with my grams of carbon monoxide. I typically will do this simply just in case I did make a mistake up here. I'm not going to make it worse by propagating that mistake. So 7.4 grams of CO. What's my first step? I'm going to convert to moles of carbon monoxide. So 1 mole of CO weighs 28.01 grams. Okay, so my units have canceled. I've gone from grams of CO to moles of CO. Okay, and now from there, grams to moles of my product. Now I get 2 moles of CO2 for every 2 moles of carbon monoxide that reacts. Now it's perfectly fine at this stage for us to say that that's a 1-to-1 ratio, but there's nothing wrong with writing 2-to-1 or 2-to-2. It's the same thing. Okay, so we've gone from grams of CO to moles of CO. Now my moles of CO cancel and I've got moles of carbon dioxide. I need to go to grams of carbon dioxide, and I'm going to use the molar mass, this time multiplying by that molar mass. 4401 grams of CO2 per 1 mole of CO2. My page is running out of space here. Oh, I can't do anything about it. Okay, so now in my calculator, I'm going to take 7.40, the grams of carbon monoxide, divided by 28.01. I can skip that step because I'm just really multiplying here by 1, and then I'm going to multiply by 44.01, and this gives me 11.6 grams of CO2.